Okay, good morning, Year 10 Hubble. Welcome to the final episode of Mr. Maltby's Home Learning Series. This is episode 11. Can you believe we've done 11 of these videos, which is great. I just want to start by saying well done to all of you working hard during lockdown, and just really impressive how you guys have all responded to the situation. So really well done. And let's get cracking with the final video. So this is a slightly different one because we'll be just looking at the required practical for this particular topic, and we'll be looking at decay. And this is a biology only, so triple practical that we need to be aware of. And of course, it's impossible for us to do this practical at home. Not impossible to do this practical at home. So we will be doing this practical in the classroom when we're back in September. But good to get the planning done and to get our heads around the kind of variables involved and why we're looking at this particular practical. So you will have got an investigation planning sheet, which we've used before, and you would have had a go at planning your own practical, okay, and done some research of your own using the internet to then plan that practical of your own. What this video is going to do today is just to go through the method and make sure that we've got all the finer details of the method. We're going to look at some example results and how we would analyse that, and how we could also do a graph to represent those results as well. So our title here is the required practical activity, and our investigation question is, investigation title is investigating the effect of temperature on the rate of decay of fresh milk by measuring pH. Okay, so just from these, and you can turn, I prefer to have it as a question, so you might have had it as a question as your investigation title. How does temperature affect the rate of decay of fresh milk by measuring pH? You could turn that into a question if you wanted to. And of course, from the investigation title or investigation question, whichever you've done on your practical planning sheet, it should include our independent variable and our dependent variable. So of course, the independent variable is the variable that we are changing, that is temperature here, and we're observing the effect of that change on the rate of decay, and we've operationalized that variable, our dependent variable, rate of decay, by measuring the pH change. So what we're doing really here is we're not strictly looking at decay, because decay takes a long time. Okay, decay, microorganisms, microbes, bacteria, they take a lot of time to decay organic matter. Okay, it's not something that you could realistically observe in a lesson. Okay, and so what we're doing here really is observing decay and modelling. So we're observing decay by modelling decay, and the way that we're doing that is by using lipase enzymes. Okay, if we think about bacteria and we think about microbes, they would use enzymes to break down the organic material. We are just providing an enzyme to model that decay. So first of all, in your reading and in the textbook and your own research, you should have been able to find out what happens when lipase is added to milk. Lipase is the enzyme, and we need to think about what is inside milk, what makes up milk, and what will then the milk be broken down into. Suggest how you might measure pH change as well. What do we know from previous topics and previous years? How do we go about measuring a change in pH? So pause the video and have a think. Okay, so just linking into the kind of objectives and some of the specification links as well. So we've got keywords at the top: lipase, fatty acids, glycerol, which we'll talk about in a minute, pH, and phenylalanine as well, which we'll refer to. We're going to be able to translate data from one form to another, picking up on specific skills here, carrying out and representing mathematical and statistical analysis, presenting observations and other data using appropriate methods. For example, we're going to be practicing the skill of drawing tables, calculating mean values, and presenting that data in a graphical form. In doing this practical, students should cover these parts of the apparatus and techniques requirements. This is part of our required practical. Use appropriate apparatus to record the volumes of liquids, in time, and pH. So, of course, these are the skills if we were doing the practical in the classroom that we'll be able to demonstrate. And don't panic, we will do this practical. The use of appropriate apparatus to measure anaerobic decay. Safe use of microorganisms as well. A measurement of rate of decay by pH change, and there we go. So what we've got here was the starter activity to get you thinking about this practical in a bit more detail. So state what happens when lipase is added to milk. First of all, we know that lipase is an enzyme that breaks down fat. And we know that there's fat inside the milk. So when lipase is added to the milk, the fat in the milk is broken down into fatty acids. It's broken down into fatty acids and glycerol as the two constituent parts. And it's the fatty acids that then lowers the pH. Okay, and we can measure that change in pH. Now, of course, what we mean by lower the pH is that it makes it more acidic. So from more alkaline to more acidic solution. Suggest how you might measure pH change. Well, there's various indicators that we could use. The video that I posted on Teams uses a slightly different one, I think, but we'll be using phenolphthalein. It's a bright purple-pink in alkali solutions, pH 8 and above, and pH below that. The phenolphthalein becomes colourless, so we're looking for that colourless change from a purple-pink colour to a more colourless changing colour. Okay, so pink, purple to more colourless. Okay, that change, we get paler, okay, as the enzyme works and produces more fatty acids, which makes it more acidic, and lowering that pH, showing us that colour change. Okay, so if you want, here we go, another little link to the specifications. We can have a pause and have a read through that. That's fine. Risk assessment, safety goggles should be worn throughout. We've got to take care of boiling water because we'll be preparing water baths. Because our independent variable is temperature, so we have to maintain those temperatures. We're going to avoid using any electrical water baths to control temperatures. We're going to use ice water and warm water from the kettle to prepare the desired temperature. This will need monitoring with a thermometer, so we've got to keep track of that. If we had lots and lots of temperature controlled water baths, that would be better, and I think we do have some, so maybe we'll be able to get those out when we do the required practical. Okay, so here's our list of equipment. Okay, the full fat milk, sodium hydrocarbonate solution, which is going to provide that alkali solution. Okay, that's important. Lipase solution, plastic syringes, beakers, test tubes, boiling tube, test tube rack, a marker pen, thermometers, stop clocks to measure the time, the phenolphthalein in a dropper bottle, and that's going to give us our indication of a pH change, electric kettle, and ice water. So the method is fairly extensive here. Okay, so this is the method that would be given from the required practical, aka required practical sheet. You may have something similar. You may have done your research and got something slightly different, but do use this method to make sure you've got the method spot on your practical planning sheet. So we're going to label 3 test tubes lipase and label 3 boiling tubes milk, or M. In the lipase test tube, put 3 centimetre cubes of lipase solution. Okay. In each of the milk tubes, boiling tubes, put 6 drops of the phenolphthalein solution. Use a syringe to add 5 centimetres cubes of the milk to each of the milk boiling tubes. Okay. And use the other syringe to add 7 centimetre cubes of the sodium hydrocarbonate solution to each of the milk boiling tubes. The solutions should be bright pink or purple. So just to make clear, we've got one tube that's labelled with lipase that just has lipase in it. We have the other test tubes that have a solution of phenolphthalein, which is our indicator, the milk, and the sodium hydrocarbonate, which provides it an alkali solution. Because we want to measure the change from alkali to more acidic once we add the lipase, but we haven't done that yet. take one milk tube and lipase tube and put in a thermometer into a bath and leave on a test tube rack at your one temperature. Okay, and this is a kind of separate method to kind of go along with the practical in terms of preparing your water bath. So create a water bath using a 250 centimeter cube beaker. Label beaker with your first temperature. Okay, now if we're doing this in school, we're going to need to do repeats of each temperature, and we'll split the class into various groups who will tackle one temperature, and just like scientists normally do, they'll share data. Okay, and we'll share the data and then analyze it. So use warm cold water until you achieve the desired temperature. Put both tubes into the water bath. Wait until the contents reach the same temperature as the water bath, and that's really important. So you're going to have your beaker of your milk solution and your lipase in a separate test tube. They've got to reach that temperature, so you've got to check and make sure they reach that temperature. When the desired temperature is achieved, using drop-in pipette to transfer 1 centimeter cube of lipase into the milk test tube, immediately start the timer. Okay, so once they've reached the desired temperature, whether that's you're looking at the 30 degrees or the 40 degrees, once they're at that temperature, that's when you add the lipase to the milk solution and you start that timer. Stir the contents of the milk boiling to slowly, and that needs to be continual, okay, to help with the reaction. Slowly with the thermometer until the solution turns from bright pink to purple to white. Record the time taken for the colour to change to white. Okay, now of course our milk is the white colour. The indicator, okay, is turning into a colourless solution. The overall change will be from pink purple to white. Repeat these steps for different temperatures and repeat experiment 2 more times. Okay, so we want repeats. And of course, we have repeats to check for our reproducibility of our data, the reliability of our data, and of course we'll exclude any anomalies when we come to that later. So, just a little reminder and recap about results tables. In our results tables, we will always have our independent variable on the left. We need to make sure with our independent variable that we have appropriate intervals. Okay. Now we need to have appropriate intervals to gather enough data in order to spot a trend. So it wouldn't make sense to have just 30, 35 and 40 degrees, for example. That's not enough. We want at least 5 different intervals of temperature, okay, to give us a broad range and to give us enough data to spot a pattern. That's one really important thing that we need to be aware of. Of course, those intervals need to be equally spaced, so we're going up in 5s here, 30, 35, 40, 45, 50 and 55 degrees C. So that independent variable is always going to feature on the left side of your table. We've got our unit. Now I would actually prefer to have the unit in brackets rather than saying in degrees C. And of course we absolutely don't put degrees C next to each of our intervals in our table. Okay, we don't do that. The right side of the table is where we write our data in, where we're collecting our dependent variable, what we are measuring. And of course we're doing 3 trials here. We would split the class up into different groups and then we would collate all of the data and work out the mean. Excluding any anomalies to ensure we have a reliability of our data. So here's some example data. Okay, so if you want to draw this table onto your investigation planning sheet, and this part of the video is to again practice those skills of calculating a mean and plotting a graph. And just as a reminder, we will actually do this practical, okay, in the classroom when we return in September, okay, which would be nice because we can have a practical in our first week back, which would be great. So pause the video, calculate the mean, and let's plot that data. So here we've got our mean scores ranging from 25 with this kind of gradual increase in time to very steep increase in time. Okay, and we can start to think about what the optimum temperature is based on our research. We can start to look at the data and the patterns and plot this data and write our conclusion. So this is an optional task, okay, because I don't want to analyse the results in too much detail, because I want to do this practical in the classroom. Okay, so we can then really think about the biology behind the results. Okay, so don't have any spoilers for that, so we can do that when we get back in the classroom. But practicing these graph skills is really, really important. So as an optional task, I'd like you to use the mean and average, time taken for solution to determine y in seconds on the y-axis and temperature on the x-axis. We always have our independent variable on the bottom of the axis. Okay, so as an optional task, you can plot the data here, the mean time taken for the solution to determine y against temperature. You start to think now about the biology behind this. Okay. What is the optimum temperature? Why is there such a steep increase in time? Okay, could it be to do with enzyme action in terms of denaturing of those enzymes? So let's have a go at this as an optional task. When we come back in September, okay, we're going to do the practical for real. We'll get real data, and we'll really think deeply about the biology behind this. Okay. So thanks very much, everybody, and I'll be on Teams should you have any questions over the next few days. If I don't speak to you on Teams, have a really great summer break. I'm really looking forward to seeing everybody back in September. Thanks a lot.